Hi everyone, in today's lesson we're going to talk about probability with the words and or. So the best way I can do this is through examples. So let's take a look at example number 1. There is a spinner with 15 equal areas, as shown in the diagram below, numbered 1 through 15. If the spinner is spun one time, what is the probability that the result is a multiple of 5 and a multiple of 2? So that word and in here is joining these two statements. We want to know what the probability is that we get the result to be a multiple of 5 and at the same time being a multiple of 2. So the best way to do this is to list out all of our possibilities. So let's list out all of the multiples of 5. So on the spinner, I'm going to highlight the ones that are multiples of 5. So we have 5, 10, and then 15. So those are the only numbers on that spinner that are multiples of 5. Then I'm going to find the multiples of 2. So I'm going to use another color to represent the multiples of 2. So we've got 2, 4, 6, 8, 10, and 12, and 14. So if we write those out, we've got the numbers 2, 4, 6, 8, 10, 12, and 14. So if I want to find out which numbers on these lists are both a multiple of 5 and simultaneously a multiple of 2, well, all I'm going to do is look for the ones that are in the same. So it looks like 10 is the same here. And it looks like that's it. There's no 5s, there's no 15s, so there's only one number out of this entire spinner that is both a multiple of 5 and a multiple of 2. So we have one number out of the total of 15 that are both a multiple of 5 and a multiple of 2. All right, let's try the second example. So the second example is a little bit more complicated. It doesn't require us to just count. So let's read it and see what we can do with it. In a certain Algebra 2 class of 25 students, 6 of them play basketball and 12 of them play baseball. There are 11 students who play neither sport. What is the probability that a student chosen at random plays both basketball and baseball? So the best way to tackle a problem like this is to use something called a two-way table. And a two-way table organizes our data in a simple way so that we can easily understand it. So either a person plays basketball or does not play basketball. They either play baseball or do not play baseball. And then this two-way table totals things going horizontally and vertically. So let's pick out the information that we have and put it into our two-way table. So it says 6 students play basketball. So where would that go? Well, if this is the plays basketball column, 6 students play basketball. So we can just put 6 for the total down here. Then it says the next piece of information is that 12 of them play baseball. So for the 12 that play baseball, that would go in this total. Number of people that play baseball would go here, so that would be 12. Then it says there are 11 students who play neither sport. So we need to find the intersection here for neither. So 11 students play neither. So would you agree that does not play basketball and does not play baseball? So does not play baseball and does not play basketball would be this intersection right here. So that would be 11. And they want to know what is the probability that a student selected at random from the class plays both baseball and basketball. So plays baseball, plays basketball. We're looking for this intersection. We want somebody who plays both. So I'm just going to highlight that this is what we are looking for, and let's find it. So what we can do is we can fill in this two-way table because we need to find the grand total, because this grand total here is the number of students in the class. And we know that the number of students actually in the class, it tells us in a certain Algebra 2 class there are 25 students. So we can go ahead and actually put 25 here. And now we can work backwards to find this total. So this 12 plus some number must equal 25. So we can count backwards. 25 minus 12 is 13. And we know that this number plus this number must equal 13. So this has to be 2. 2 plus 11 is 13. And we know that 6 plus this number must equal 25. So 25 minus 6 is 19. And we know that the total number that do not play basketball, if this is a total of 19, so 11 plus what adds up to 19, so that's 8. And then last but not least, 8 plus this must add up to 12. So 8 plus 4 gives me 12. So the probability that a student plays both baseball and basketball is right here, 4 out of the grand total of 25. And that is your probability. All right, let's do an example with or now. Okay, so same concept with the spinner. There is a spinner with 15 equal areas, numbered 1 through 15, like so. If the spinner is spun one time, what is the probability that the result is a multiple of 3 or a multiple of 4? So I'm going to highlight all of the multiples of 3. So 3, 6, 9, 12, and 15. And then I'm going to highlight all of the multiples of 4. So 4, 8, 12, and that would be it, 4, 8, and 12. So if I'm doing the multiples of 3, we had 3, 6, 9, 12, and 15. And multiples of 4 were 4, 8, and 12. So I want to know what's the probability that this result is this or this. So all we have to do is just add them all up. Just make sure you don't count any doubles. So we have 3, 6, 9, 12, and 15. I'm just writing down the multiples of 3. And now let's add on the unique multiples of 4. So we've got 4 and 8. But I'm not going to add this 12, right? We don't need to add it twice because the 12 was already added. So that's the idea with or. You actually don't want to add it more than once. So 1, 2, 3, 4, 5, 6, 7. So this one is 7 over the total of 15. And that is your probability. All right, let's move on to example number 2. So similar to example number 2 from the previous page, we're going to have to use a two-way table. So let's see what information they give us. It says in a class of 26 students. So we know the grand total goes in the corner. So we can actually go ahead and label 26 here. It says 16 of them play basketball. So the grand total of basketball is 16. So that goes here, grand total. Then it says 9 of them play baseball. So the grand total for baseball needs to be 9. So that has to go in the corner here. And then it tells us that there are 5 students that play both sport. So 5 students who play both. So the intersection, plays baseball, plays basketball, right in here, would be 5. And they want to know what is the probability that a student chosen at random from the class plays baseball, basketball, or baseball. But before we can do that, let's actually fill in the rest of this two-way table. So take a minute, pause the video, fill in the spots, and then hit resume when you're ready for the answers. All right, here they are. All right, so now we have to locate where is the probability that a person plays basketball or baseball. So let's highlight the areas that makes most sense. So a person that plays baseball and basketball would be here. A person that plays baseball only would be here. And a person that plays basketball only would be here. So those would be the 3 areas that we need to add up. We would not include this area because that's the area that a person does not play either sport. So this would be 5 plus 11 plus 4. So that adds up to 20. So 20 out of the grand total, which is 26. So the probability would be 20 out of 26, Or if I reduce it by dividing top and bottom by 2, I would get 10 over 13. And that would be that exact probability. So that's it for today. If you guys have any other questions, please let me know. Otherwise, we'll touch base tomorrow. Have a good night.